We're pen test partners, and we're going to be cooking up a storm with Android today. Now, some of you may have come across us in the past. So we used to look at iPads and iPhones, and we hacked them at the last 3 InfoSecs. We thought it'd only be fair to have a go at Android this time. So what we want to know is, are Android phones suitable for use in a corporate environment? Can you connect them to Exchange and do your email on them safely? And all these security products that are being sold, so you can do BYOD, bring your own device, mobile device management, MDM, are they actually any good at securing these devices? So who are we? Well, we're pen test partners, and we're all about helping you secure your systems, testing the security of them, mobile devices, mobile apps. If you do mobile banking in the UK, it's pretty much very likely that we'll have been involved in the pen testing of those devices. Now, here's the Android phone I'm going to have a go at. It's starting to fall apart a bit, actually. I think we might have over-hacked it, don't you? It's pin-locked, it's encrypted, and it's got an MDM product running on it as well. Now, in the past, if I wanted to unlock it and get the pin, what I'd probably do is get it into a freezer bag. Then I'd get my oven warm, I'd get up to about 50 degrees, and I would bake it for about 20 minutes with a few drops of cyanoacrylate or super glue. Now what happens is the glue heats up, it goes airborne, and it starts to react with the screen. Now it trashes the screen, so I'm not going to do it, but I can start to see the grease smears where you put your pin in, recover it that way. Now, I talked to Infosec, and we told them we were going to cook superglue, to which they put their arms up and said, there's no way you can cook superglue live on stage. You'll have people getting ill, tripping, having hallucinations, to which I said, well, celebrity chefs, they're not known for substance abuse, are they? I don't know. So the other thing you need to know is if you're seizing a phone for forensic purposes, or you're hacking it, you need to get it into a Faraday cage quickly, otherwise it'll be remote wiped. So you could use a Faraday bag like that, or if you happen to be in the kitchen, you could use the best Faraday cage around, which is a microwave. If you get your phone in there, there's no RF going in and there's none coming out. I just wouldn't recommend turning the microwave on, because you might lose rather more than your data. So we can't cook it, can't bake it, can't microwave it. Ian, how are we going to hack this?
Cheers, Ken. Thanks for the tenuous kitchen links and making me dress up as a chef.
You're welcome.
This is the Nexus 4. We have got 4 different ones in various states of the construction along the bench. We're going to do 4 attacks on these Android phones. I've already kind of slightly started to take this one apart. The camera's gone and there was another baseboard above it. But I just want to quickly, obviously Ken mentioned that the first thing you want to do is obviously prevent it from phoning home. You can put it in a microwave, but you can't do much with it once it's in there. This little thing here, this little pigtail is the aerial, so you can just take that out and it won't phone home. But the most important, well, the thing that we're really going to concentrate on this demo, if I zoom in, right next to the LED flash, just show you the side of it as well. That's the JTAG port. That's the debug port that allows us to go kind of a lower level. And Ken's going to briefly kind of like talk about it a bit later on. But I am going to talk about the default Android security, kind of what prevents you from just plugging in your Android phone and getting access to the data. So, right, MDM product. You've connected your phone to your Exchange, your MDM product's gone, right, so he sent down a policy, he said, I want encryption on, I want complex passwords, I want any less than like 8 characters. The Android says, yeah, that's fine, I've got my default encryption on, I'm not accepting any weak passwords. So they agree upon that, that's fine, emails go backwards and forwards, and there's corporate data on the handset. Now, as a normal user, you can't just, well, you can connect it up to your Windows operating system and gain access via USB once you've unlocked it. However, you just get access to like your pictures, your music, and your videos and things like that. We want to go lower level than that. We want to get to the user data partition, which contains all of the sensitive username and passwords. So bear that in mind. Bootloaders I'm going to talk about in a second. Ken's going to talk about the Android Debug Bridge and do a demo on that in a little while as well. So right, going really fast, bootloaders, the left-hand side there, that's the process of when you turn on your device, it goes to the bootloader. The bootloader's like a little mini operating system, it kind of gets everything ready for the Android device. And by default, all new Android phones come with their bootloader locked. What this means is I can't create my own firmware and put it onto the phone and then kind of read the actual flash memory. They don't let you do that. You have to have it signed by LG or HTC. However, due to the open source nature of the Android, some of the manufacturers have actually let you unlock your bootloader yourself. but this process also wipes the user data partition, which is kind of no good for us. We want all the data to kind of stay intact. The reason why they do that, they don't really care that they're deleting your personal data. It's the DRM content they want wiped. They don't, that's the most important thing to them. Recovery mode also is another feature of the bootloader. Allows you to load firmware to RAM. You can do other bits and pieces with it. There's a couple of ways and means of actually unlocking bootloaders without wiping the data, and that's through use of gold and white cards. These are kind of a bit unknown at the moment. They're normally used by police authorities and central government agencies that live in donuts. You can actually emulate the same kind of techniques they use here. If you want to come up to me later on, I'll show you how it's kind of done. It's a bit above this demo, to be honest. But
so, are you saying that the NSA and GCHQ have got root access to our Android handsets with these gold cards?
I don't know.
Are we surprised? I guess not. So anyway, today we're going to be talking about JTAG, Joint Test Action Group. And it's a series of low-level connections that you can make, typically used by firmware developers. So they'll be using it so they can stop the CPU clock and cycle through step by step so they can see where their firmware needs debugged and fix it properly. Now, I've got a Samsung handset over here. We'll pop it up on screen just now. Waiting for it to come up. Now, all I'm going to do is remove the back of the handset. Really straightforward to do. It's not complicated. Put it live there, and straight away we see the JTAG ports. They're really obvious. If you can see there, those are the JTAG ports. They're nice and sizable. They're well isolated from the rest of the chip. I'm going to need a little connector like this. Get it for a few bucks on eBay. And if you see here, the connector lines up with the JTAG ports. I then put it in, I turn it over, I connect it, and I hold it in place with an elastic band. Then I can start talking with the JTAG protocol down this connector, which is great. This is where Apple deserve a bit of a high five, actually, because they've made their JTAG connections really difficult to talk to. If you can get that degree of access to a chipset, you can do all sorts of crazy hacking stuff with it. So here's my 3GS. I've done a quick teardown on it. Now, underneath this, on this baseband, which there's the chip capping, you've got the pin-out diagram here. This is actually one from an iPhone 4. The pins here are the JTAG ports. Those are the ones we're interested in. You can actually see them a bit more clearly on the back of this one from the 3GS. Some Bright Spark worked out what they were a little while back, and you can see tiny, tiny ports. That one there is the clock, and the 5 over here are the rest of the JTAG connections. But, like most vendors, Apple haven't published their JTAG protocols. The other big problem I have is you try micro-soldering to those connections. I hope you've got a steadier hand than me, because I can't hold it anything like close enough. Because the protocols aren't known, it makes it very, very difficult to talk JTAG to them. So what you're going to need in that particular case is something like this. This is a JTAGulator, put together by a guy called Joe Grand. And what it can allow you to do is, first of all, identify the pinouts that actually deal with JTAG. It can then help scan across them and find which each pin does, which function it has. And finally, it can help you also start to reverse engineer the JTAG protocol to give you a chance of understanding what it's doing. Now that's a bit functional for what we're going to be doing. We're going to be doing something specifically designed for mobile phones. Ian, tell us about the Riftbox.
Right, cool. So Riftbox, you can get it from eBay. It's about 100 quid. These are primarily used by those dodgy mobile phone shops you get in every high street that you go into to get your phone unlocked to use on any network. This is what they kind of use for that. You can also change like IMEI numbers for like stolen handsets, but yeah, we're not going to do that on this one. We're just going to concentrate on the JTAG connection. I've got it all set up down here. I've got the JTAG ribbon cable connected up to my Nexus 4, and then my USB is actually connected up to my laptop. And as Ken mentioned with his Samsung one, here's one that you can just get off eBay, a couple of £1 again. A Riftbox connector just goes straight onto that. And then this little connector is the male version of the one I showed you earlier on, right at the beginning. So I've just got that clamped on just there. Just going to load up the manager software so you can have a look exactly what it's doing. The reason why we're using the Riftbox is because it's got a massive database of all the mobile phones out there with all the JTAG protocols, all of the JTAG pinouts, all the memory locations and things like that, so we don't have to reinvent the wheel. I've got it here, if you can see, the LG E960, which is the Nexus 4. I've already got that selected, and hopefully when I click go, yep, cool. So it's got an ID there from what it's called a dead body. Next thing we want to do is analyze the JTAG chain. And what this does, within a JTAG connection, you can have many tap devices. And what it's found there at the bottom is found a Qualcomm chip, which is basically the radio, and then the one that it really hasn't identified is next is the CPU. So we can talk to both of those on the lower levels. So that's pretty cool. But the really good stuff is in this plugin here. So as Android is based on a Linux operating system, I'll just bring it out so you can kind of see it. what this plugin does, it loads the partition table of the flash memory of the mobile phone. So the guys that are familiar with Linux, you can kind of see a couple of ones that are similar there, but the one I mentioned earlier on is the user data one. So that's the one that's encrypted. In its default state, Android encryption will only encrypt that user data partition and nothing else. So the rest of these partitions are readable by us. So this metadata one here is the next one we really want to look at. If I just click read over here, it goes off and does all the memory location stuff, and hopefully it will come back. So cool. You probably can't see that, but basically what it says is AES-CBC. So we know it's all the cipher stuff. What also is contained in there is the master key and the salt. So they're the two bits of information we only need to actually kind of brute force the encryption. If we go next on the slide, Ken. The way that the encryption works, so you've got your PIN, it takes the PIN, it gets some random data, it then takes the salt and does some magical stuff with the MD5 hashing technique, and then creates the master key, and then pumps that through de-encrypt, and then you get the encrypted user data partition. We're basically going to be doing the reverse of that. Now, the problem with the Rift box is it's, the throughput from the box to our laptop is quite slow. It's 100K a second, so to get 8 gig from there, it's going to take quite a while, so I'm not going to do that. I've already grabbed an image here. I'm just going to show you. I've done a 8 meg dump just to speed things up, and I've already dumped the metadata partition. I'm going to use two tools from a guy called Tom Cannon. He's pretty elite Android reverse engineerist. You can do a search from on Google and you can get these scripts. They're all open source. So, right, what we need here, it's a Python script. I give it the header file, which is the 8 meg dump, and then the metadata, which is all the crypto stuff. And then 4 is the length of the PIN, so hopefully that will go off. Cool, so that's gone off and it's got all the salt and the encrypted key for the meta stuff, meta partition. This isn't the latest version of Android. Latest version 4.4 doesn't use MD5 to do the hashing technique. It uses script. Script is slightly harder to, it's computationally harder to process, so it takes longer to create these hashes. So this would take longer on my CPU, but you could kind of buy graphics cards and actually accelerate the cracking. Okay, that's cool. Right, we've got the PIN 1337, so we could log onto the device, we could read his email, we could browse his Facebook and look at his cat pictures, but we don't really want to do that. We want to get the actual user data partition to get the sensitive data. I want VPN creds, I want private keys, I want that, everything basically. So because Android is based on Linux, I can decrypt the partition and just mount it here. So I'm just going to quickly run another proof of concept tool by Tom just to prove that it's actually decrypting. So 8 meg dump 1337 goes through and it does the whole crypto stuff at the top again, and then we've got all the decrypted data. I'm not entirely sure why it does all the zeros at the top there. You just got to believe me, there's data further down the image. So I've got the image already. I've already decrypted it and I've mounted it here on this other window. I'm just going to quickly go into the directory that contains the database for the email. Now, a lot of the programs within Android store its data within SQLite databases. So I'm just going to load that database up now. Not start another terminal. So SQLite email provider.database, and then I'm just going to do a quick query here, select everything from host auth. So awesome. I've got his email address there and his password in clear text, which is just crazy.
That's just mind-blowing. So a few minutes with a bit of hardware hacking and a Rift box, and you've got clear text passwords out.
And cat pictures.
And cat pictures. You've got to have your cat pictures, just not the same. Now, I don't know, maybe you don't fancy you trying JTAG. Maybe you just want to use a USB cable. Anyone here got a Tesco huddle yet? Really cheap from Tesco, about 120 quid entry level. Now, it's cheap. One of the reasons is because it uses a cheap CPU, the Rock chip. And unfortunately, the Rock chip comes with a wonderful vulnerability in its bootloader. So here is a pin-locked huddle. I need to get it into bootloader mode to start with, so I'm going to need a dibber. I want you to hold down the volume up. I get my dibber out, put it in, take it out, release volume up. That gets it into the Rock chip bootloader. The vulnerability is, once it's in bootloader mode, not only can I write to the device, I can also read from it as well. So, mad. I've got a pin-locked huddle over here. It's connected to my machine using a USB cable. Got it up here. I've got a script running. There we go. I'm now talking to the memory of the huddle. So let's say we want to read the memory. I'm going to go for a very specific area of memory. That's the start of the user data partition. I'm going to read for the first 1,000 bytes. I'm going to pipe them out to a temporary directory. There we go. We're now reading memory. Okay, that's very interesting, but what can I get from that? It takes a couple of hours to read the whole of the user data partition. So I've mounted one earlier. Let's have a little look and see what we can find in here. It takes a couple of hours to actually extract the entire user data partition, but here's what I did earlier. I've mounted it. Let's see what's in the passwords. There we go. I've got a hashed password back already, so I could crack that with something like Hashcat, but that's not good enough for me. I want to see if the huddle actually starts storing plain text information. So I'm going to go have a look at the wireless keys. Let's have a look and see how it stores them. There you go. Plain text storage of WPA keys. So that's a pin-locked huddle, and I'm stealing plain text secrets. That's just nuts. Okay. It's domestic grade kit, this, clearly. Although I would have expected a bit more security. I don't know about you. Clearly not suitable for use in the business, but let's say we spend a bit more money and go for some business grade kit. So here is Samsung S4. Now Samsung know that the crypto on default Android is a bit rubbish, really. So they've written their own, but unfortunately that was broken by a project called Sandy quite recently. I would demo that, but it takes a little while, so I'm going to move on from there. But clearly, you can see that even if you spend bucks on higher grade Android gear, it's still really not very secure. Now, why on earth have we got a fridge freezer on the stand? Maybe it's there just to keep my beer cool, keep me happy, but actually it's part of the demo. We need it in order to keep something quite cold in the freezer. Ian?
This is yet another Nexus 4. It's slightly colder than the rest of them. We're going to do the cold boot attack on this one. At the moment, this device is on. It's got its pin cached in RAM. Now, what we're going to try and do is we're trying to get an image actually onto the device to then search with the RAM to actually retrieve the key. For you guys that don't know, whenever you turn off a device, the RAM just disappears. It's not persistent like flash memory, so that's the reason why we're chilling it. We want to be able to reboot the device quickly, because when it's cold, the degradation of the actual memory chip slows down, so we can take the battery out, put it back in again really, really quickly, get it into bootloader mode, and then upload the recovery image. I'm not going to do that live because it just won't work. I've got one here already uploaded. The Frost image is pretty cool. It's got a whole load of other options, but the one that we want is, like I said, I'm just going to start it. It will go through the RAM and search for the key. The only caveat with this one is that to get the image onto the device itself, you need the bootloader unlocked, like I mentioned earlier on. So you can't use this one in every situation, but you can unlock the bootloader with those gold and white cards. So hopefully, let's leave that running, and then let's come back to it. Keep an eye on it.
Keep an eye up there, and I'm going to talk about the Android Debug Bridge whilst that cracks. So ADB, Android Debug Bridge, typically used in order to debug Android applications when you're writing them. So developers use it before they put stuff in the Google Play Store. However, it also has other functions. So ADB, you also need to enable that if you want to root your device. A bit like jailbreaking an iPhone. However, there we go, look, we've got the Frost crack. We've got the pin out, fantastic. So back to ADB. You really don't want rooted or jailbroken devices on your network. And that's usually what you use an MDM, a mobile device management product, to stop. They're supposed to check to see if the device is rooted, and they say, no, you can't come anywhere near my network because you're really insecure. Unfortunately, they're quite easy to work around. You might use tools like the Cydia XCon framework, and that can stop the MDM detecting whether you've jailbroken or rooted your phone. So we've got an ADB-enabled rooted handset over here. I'm going to show that on screen in a moment. And they're going to show you how you can brute force this. Now, we mentioned this to Google a while back, and they came back and said it was a feature of the Android Debug Bridge. Well, we kind of feel it's more of a vulnerability because we can use it to brute force pins and crack into phones. Well, hey, who are we to say Google? So there's another attack works quite similar to this called the rubber ducky exploit. The downside with that one is you have to watch the screen for 14 hours as it unlocks the 4-digit pin, because when it finds the pin, after 5 seconds it relocks again. Now our one, we use different features of the Android SDK, and we actually tell you what the pin is. So hopefully we've got our handset up there, my scripts are running here, I can get that running. I'm connected over a USB cable. I love this one because I don't have to touch the phone. It's magic, it's ghostly. There we go, you see the phone's brute forcing itself? Now of course, it's not 133, it's 3336, we're elite, so it's 1337, there we go. We've now unlocked the phone. That is absolutely nuts. So whatever you do, don't enable ADB mode. Now, people say to me, well, that's 4 digits, that's easy. My pin's loads longer than that, so you haven't got a hope. Well, there's a problem there because people often use patterns for long pins on Android devices. And of course, as a result of a pattern, you don't reuse numbers. And that massively reduces the entropy of your pin. So with a 6-digit pin, potentially 1 million combinations. Pattern pin, down to about 1,500. So please, Android, long pins, don't use patterns. Now, the last problem we've got is that handset we stole, well, it's going to be reported stolen, the domain creds will be expired very quickly, I'm sure, the VPN keys will be expired, and we'll have a bit of a problem because all we've got is offline access to data on that phone. I want to use that phone to get access to the business though. How am I going to make my attack persistent, Ian?
Okay, so cool. All we do is we write a piece of malware for the Android operating system that just connects back to us, that's continue, I don't know, sniffing for the sensitive data. We then publish it to the Google Play Store. Now, the security checks that Google do aren't as thorough as the ones that Apple and Microsoft do, so it is quite easy to get a bit of dodgy code actually into the Google Play Store for anyone to download. So, okay, we've cracked their PIN. It's taken like 30 seconds. On the old device, we then install it from the Google Play Store on the old one. We then accept all the permissions because we're nice like that and we want to make sure he's okay. And then this is the clever bit, we then force a backup. What that backup then does, it lists all the applications that are installed in the phone, like Twitter, Facebook, Candy Crush Saga, including our piece of malware. And then when he gets his new shiny Nexus 5, he clicks restore, bang, 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 all of the applications come down, including our dodgy piece of malware.
Blinding. So we put a dodgy app in the Google Play Store, and we have control of the stolen handset so we can download it. We then force a backup, so when he tries to restore to his new phone, he doesn't realize he's bringing down our malware as well. Awesome. Nice persistent attacks, so then we can hack the business. Now, how would you go about mitigating this stuff? Well, first of all, you've got to keep your Android version bang up to date, but even that won't help you solve everything. It just makes it a little bit more difficult. You might put in a mobile device management platform, an MDM, that's supposed to help secure this. I think we've already shown you that exploits frameworks like Cydia or XCon actually stop those MDMs being effective for you. There are a couple of MDMs on the market that work a bit differently though. They have a separate encrypted container that works independently of the Android operating system crypto, and they do work a lot better. I'm not going to name them because that wouldn't be fair, but some of them might be quite good. Anyway, who are we? Well, we're pen test partners, and we do high-end pen testing on mobile devices, mobile apps, web applications, and we do a lot of forensic investigations too. Now, what about that bit of malware we had? So over here, we've now got the guy's new phone. We're going to get that up on screen in just a moment. And what have we got? So we've got the new phone. Of course, we know the PIN now, and he's restored our malware without realizing it. We pops it on the desktop so you can see it, and of course it contains the best giveaway at InfoSec, Pen Test Partners socks. I hope you all enjoyed the demo. If you've got any questions, we've got a recipe card here for you which tells you how to do all the attacks. Please don't go breaching the Computer Misuse Act while you do it. And also a forensic bag here to put any C stuff and a nice stick of rock to chew on while you deal with the incident. Thank you everyone, hope you enjoyed it. Here come the socks.